Hello everyone, welcome to my class, Math Lesson with Miss Kenny. This is video part 3. You have learned about special lines, the vertical line and horizontal line. They are linear functions with one variable. Now you are going to learn how to plot graphs of linear functions with two variables, the x and y variables. For example, y equals x plus 3. So the y variable, the coefficient of the y variable is 1. If the coefficient of a variable is 1, no need to write down the coefficient such as y. Y variable is always on the left side of the equal sign. The x variable is always on the right side of the equal sign. And then this positive 3 is a constant. It's always on the right side of the equal sign. Now, to plot a graph, you need table of value. The first column is x on the first row, y on the second row. Okay, we need inputs. X coordinates are the inputs here. Okay. You can choose any value of the x coordinates. I choose -1, 0, and 1. And then use this x coordinate to input to find the output. So if the x coordinate is -1, the y coordinate is 2. Okay, because -1 plus 3 equals 2. If the x coordinate is 0, the y coordinate is 3. If the x coordinate is 1, the y coordinate is 4. Okay, from the equation here. Now, you have 3 points here. You can plot the graph. Okay, I'm using the second and the first quadrant because the x is start from negative to positive, and the y coordinates all have a positive sign. Start from the first point, -1, 2. It means go to the left 1 step, go up 2 steps here. 0, 3 means from the origin, no horizontal movement, and then go up 3 steps. The third point is 1, 4. It means go to the right 1 step and then go up 4 steps. And then connect these 3 points and then label. Now we have done plotting the graph. This is how we plot the graph. First, create the table of value. Choose the inputs here. You can be free to choose the inputs here, but not too big. Okay. Now, the second example. See this example. Y equals -2x plus 4. Y is always on the left side of the equal sign. The x variable is always on the right side of the equal sign, and then the constant +4 is always on the right side of the equal sign. Let's generate the table of value. Choose the value of the x coordinates. Okay, -1, 0, and 1. And use this x coordinate as input to get the output. Okay, use this formula. For example, if x equals -1, it means -2 times -1 plus 4. -2 times -1, negative times negatives equals positive. So 2 plus 4 equals 6, like this. And then if x is 0, and then -2 times 0 equals 0. 0 plus 4, 4. The y coordinate is 4. And then if the x is 1, we need to calculate this using this formula. Okay, if x is 1, then y is 2. Now we have 3 points. It's time to plot the graph. Plot the point on the graph. Okay, the first point, -1, 6. It means go to the left 1 step and then go up 6 steps here. And then the second point, 0, 4, no horizontal movement from origin, go up 4 steps. And then 1, 2, it means go to the right 1 step and then go up 2 steps. Okay, now connect the points it must be a straight line, and then label the graph. Now we have the graph. Okay, this is how we plot the graphs of linear functions. Now we compare from the first example and then from the second example. Okay, compare these two graphs, linear graphs here. See, the first example, the graph or the line cuts the y-axis at 3. The second example, the line cuts the y-axis at 4. So 3, we call this y-intercept. Okay, for the first example, the y-intercept, the value of the y-intercept is 3. For the second example, the value of the y-intercept is 4. Okay, you can recognize this without drawing the graph, just by looking at the equation. See, the constant here, okay, is the y-intercept. See, without drawing, you can recognize. As long as you put the y variable on the left, and remember the coefficient of the y variable must be 1. Okay. Now, the point of the y-intercept is the coordinates of the point 0, 3 for the first example. What about the second example? The coordinates of the y-intercept is 0, 4. This is 0, 4. This is 0, 3. Now, you've learned about y-intercept. Now it's time to learn about x-intercept. Okay, the x-intercept. For the x-intercept, you need to extend the graph. For example, the first example, the first graph, the graph on the left, it's not long enough, so you need to extend the line and then draw the graphs here. Extend the line until the line cuts the x-axis. We call this x-intercept. The value of the x-intercept is -3. Okay, the coordinates of the x-intercept is -3, 0. The coordinate of the y-intercept is this here, the coordinates 0, 3. Okay, for the second example, the second graph, see the line is not long enough, so we need to extend the line until the line cuts the x-axis. So the line cuts the x-axis at 2. Okay, cut the x-axis at 2. So this is the x-intercept. The coordinates of the x-intercept is 2, 0. Okay, you have learned about y-intercept and x-intercept. Now, still comparing two graphs. Now we learn about gradients of linear functions. The gradient of a line is a measure of its steepness. It means how steep a line is. Gradient or the slope here. So, first let's take a look at the direction. Both lines, okay, have different directions. For example, the first graph, the graph on the left here, okay, if you move from left to right, okay, you are moving up here, moving up. So the graph on the left has positive gradient because you are moving up from left to right. But what about the graph on the right? Okay, from left, okay, imagine here, you are moving down. So the gradient of the graph on the right, gradient has negative value. Okay, so if the graph on the left is positive, what about the size? The size of the slope or the size of the gradient of the graph on the left. Let's see. Okay, let's see the rise, okay, and the run, or you can say the height of a triangle. Create a triangle, right angle triangle, and then measure the height and the base here. Okay, so the gradient of a line is the ratio of the rise to the run. So 2 to 2. We simplify equals 1. Okay. See, you can see the gradient from just looking at the linear functions. Okay, the coefficient of the x variable is the gradient. Okay, without calculating, here you can see from the linear function here. Okay, sometimes the question, okay, or the problem that you are going to deal with is that the equation is not given, so you need to find the equation here. This equation, the equation of the graph is not given, so you cannot find the y-intercept and the gradient just by looking at the equation. Okay, next, the second example. Let's find the height of the rise or the rise, okay, and the run or the base. So gradient is the ratio of the rise to the run. The rise is 4, the run is 2. So 4 divided by 2 equals 2. Don't forget the sign, the direction, negative. You can see the gradient just by looking at the linear function. Okay, but the problem is sometimes you just given the graph and not the equation. Okay, so for the first example, for example, this is the linear functions. Just from this you can predict the y-intercept. The y-intercept is 3, and then the gradient is the coefficient of the y variable. Just as easy as that. Now, for the second example, you can just spot the y-intercept immediately and the gradient immediately. Please pay attention that the coefficient of the y variable must be equal to 1. Okay. Okay, that's why we can formulate the general equation of straight line like this. See, y is always, the coefficient of y is always 1. So we call this gradient intercept form. Gradient, it means this m, the gradient, and then the intercept is the c, this one. That's why we call this gradient intercept form. Now, let's see the arithmetic sequence here. From here, you can recognize, can you recognize this? So this is the graph. Can you recognize it? The gradient, okay, the rise is 4, the run is 2, so from left moving up to right, so it has positive gradient, and the size is 2. What about the y-intercept? The graph is not long enough, we need to extend the line, and then we get the y-intercept equals -1. So the gradient of a line is 2, then the y-intercept is 1. That's it for today. Thank you for watching.